This is Venus as it might have once been, a world with vast oceans, clear skies and a climate that may have supported life. But it's a paradise that didn't last. Powerful volcanic eruptions began to reshape the planet, releasing vast amounts of carbon dioxide, sulfur dioxide and water vapour into the atmosphere. And as these greenhouse gases built up, they trapped heat, causing the oceans to evaporate and their water vapour to break apart, with hydrogen escaping into space. The once blue skies thickened into dense clouds of sulfuric acid, turning Venus into a scorching, hostile world. Yet this transformation may have happened much later than you'd think, possibly only 800 million years ago. To put that in perspective, life on Earth had already been thriving for over 2.5 billion years by that time, with microbes having taken hold in Earth's oceans 3.5 billion years ago, evolving steadily in a world that offered all the ingredients of a habitable world for life to take hold. But could Venus have followed a similar path by fostering microbial life in its ancient oceans, only to lose it when it turned against itself? If this is the case, the story of Venus looks like one of incredible loss, where conditions for life existed long enough before the volcanic apocalypse sealed its fate. Or did the process of life find a way to adapt to its changing environment? Venus is often called Earth's sister planet. It's nearly the same size, has similar composition, orbiting just a little closer to the Sun, and like Earth, it's a rocky world wrapped in a thick atmosphere. But here the similarities end, as while Earth nurtured life, the searing inferno of Venus diverges into a twisted reflection of what it could have been. The planet's thick atmosphere is almost entirely carbon dioxide, with dense clouds of sulfuric acid suspended within, a mix that has triggered a runaway greenhouse effect, trapping heat so effectively that temperatures at the surface now soar to 475 degrees Celsius, hot enough to incinerate most carbon-based life forms we know. And then there's the pressure. At 92 times greater than Earth's, it's equivalent to being 3,000 feet underwater. If you stood on Venus's surface, you'd be crushed in seconds, feeling the weight of an entire ocean pressing down on you as you desperately tried to draw just one breath. Yet as inhospitable as the surface has become, some scientists have turned their gaze upwards into the planet's toxic atmosphere, where the environment is revealing more surprises than we once thought possible. Amid the oppressive heat and crushing pressure on the surface of Venus, an intriguing possibility has come to light high up in the clouds, one that could hold the key to understanding Venus's potential for life. The upper layers of its atmosphere offer surprisingly temperate conditions. At around 50 kilometers up, the temperature drops to a mild 20 degrees Celsius, with pressure levels a more forgiving 1 atmosphere, similar to what we experience at sea level on Earth. Here, far from the hostile conditions on the surface, the upper atmosphere could become a potential haven for life, where microbial organisms might find a niche to flourish. It's something that may be happening now because in 2020, scientists announced the detection of phosphine in these clouds, a gas that on Earth is typically associated with biological processes. The discovery ignited excitement at first, but was followed by controversy regarding the accuracy of the readings. Yet recent observations made by the same team have backed up those original claims, along with other studies suggesting that the clouds may hold more than just acidic vapours. Adding to the mystery is the tentative detection of ammonia, another gas often linked to biological activity on Earth, which might even help neutralise the acidic environment, creating a more habitable niche for life. It's a search that NASA's Da Vinci mission, due to launch in the early 2030s, will be uniquely equipped to help us with, as it will directly sample Venus's atmosphere. In the meantime, the search is compelling even with ground-based equipment, as the variability of phosphine levels seems to fluctuate with Venus's day-night cycle, higher during the planet's nighttime and diminishing in the sunlight. It's a pattern suggesting dynamic processes in the atmosphere that remain a mystery. Could it be evidence of life adapting to its environment, or is it the signature of a chemical reaction we have yet to understand? Whatever the answers, the Da Vinci mission's insights will bring us closer to understanding Venus's past and its atmospheric secrets, which may just reshape our understanding of where life might find a way, even in places we least expect. As the work of evolutionary biologist Stephen Jay Gould suggested, life is a process which is never complete, a continuous thread of forms endlessly adapting to a changing environment. Perhaps somewhere in the clouds of Venus that thread continues, endlessly adapting, refusing to be broken, regardless of what the planet has thrown at it.